Produced by PI Media.
At the end of last year, a social app was published on the Ethereum network. It was a cute little game, very PG, very simple in concept. Within just 1 week, it became so popular that it threatened to take down the entire Ethereum platform.
Blockchain.
Hi, I'm Nate Nelson. Welcome to the Orbs podcast. In today's episode, I'm going to introduce you to a concept which, if implemented correctly, could have saved Ethereum an existential crisis back in December of 2017. To properly grasp what I mean by this, let's first take a step back. How do you ensure the quality of something you buy before you buy it? Each industry has its own means for customers to exercise quality assurance. Clothing stores have dressing rooms where you can try on items and make sure they fit and look good on you. Online retailers have free return policies. Movies get reviewed to give some indication of whether a picture is worth your money, and so on. The internet, however, is less easily pinned down than, say, clothing or movies. When you enter into a contract with an internet service provider or purchase an app, there aren't many good ways of determining beforehand exactly what to expect. You can rely on their marketing materials or search the internet for customer reviews. But setting up new Wi-Fi isn't like trying on clothes. That's why service level agreement, or SLA for short, is important. SLA is no more complicated than it sounds. It's a predefined contract detailing the level of service a customer can expect from a service provider. As just one example, Amazon's cloud compute service comes with an SLA which, among other things, ensures that the platform will be up and running at least 99.99% of the time. If that standard is not met, customers are eligible to receive credits to their accounts. SLA can be business to customer, or business to business, even intra-organizational. Naturally, there's variation in SLA between industries based on what sorts of services are being provided. In cloud computing, for example, it's standard to have service-level agreements for each individual component of the platform, whether it be, say, networking, computing, or storage. The main point here is that service-level agreement allows two parties to come to a mutual understanding. It provides quality assurance for customers and protects service providers from the sorts of misunderstandings that leads to lawsuits and angry letters. From a legal perspective, it's a win-win situation. What could go wrong? Well, here's a scenario. How do you have a service level agreement without two parties? If you have a problem with your internet connection, you can take it up with your ISP. If you buy a sweater that itches, you can go back to the store and see if they'll give you a refund. In a decentralized architecture, there is no defined second party with which to take up issue. It's sort of like a football game with only one team. How can you play a game without anyone to play with? Here you have one side of the contract, the user, and then who's on the other side? 10,000 other users with no particular responsibility to you. To get some sense of how SLA might work in a decentralized context, I spoke with an expert on exactly this matter.
Hi, I'm Oded Noam. I'm the Chief Architect of Orbs.
When you get your service from a decentralized system, such as a blockchain, then there's no single entity that you're dealing with. So that raises a whole question. If you want to purchase an SLA, you want to pay somebody to guarantee a certain service level, then who should that body be? Who can guarantee anything if you don't know who you're dealing with, if you're dealing with a group where nobody is in charge? And that is a very general problem of providing SLA in a decentralized context.
So here we have a conflict. Decentralized infrastructure provides no obvious solution to how to handle SLA. But without SLA, blockchain providers have little hope of attracting real-world businesses, which need these sorts of contractual agreements in order to stay out of legal trouble and do right by their customers. At the end of last year, the blockchain universe experienced a major lesson in why this is a matter worth giving some time to. In a previous episode of the podcast, and at the beginning of this show, I briefly alluded to CryptoKitties, a social game where participants can buy and sell and groom, I guess, virtual kittens. The kittens, they're kind of cute with these giant beady eyes and colorful fur patterns, and no two CryptoKitties are exactly alike. The game, it turns out, was an instant hit. As one of the first major applications of decentralized technology for the purposes of leisure, it seems to have come at the right place and right time, and in only those first days after its release, it managed to take up a whole 20% of the entire Ethereum platform's traffic. In all, it was an enormous success, and in another sense, a huge red flag.
Blockchain.
At any given point on November 29th, the Ethereum network was processing about 100 to 2,000 pending transactions. By December 4th, the platform had a stockpile of over 11,000 backlog transactions yet unprocessed. That represents a six-fold increase, one which slowed down the entire Ethereum network and everything running on it. What at once may have appeared to be a great success for Ethereum, its first mega popular game, demonstrating the platform's versatility and future potential as an app marketplace, ended up a kind of major failure. All of the other apps running on the Ethereum network experienced major slowdowns through no fault of their own as a result of a separate app that they had nothing to do with. Developers finally came to see the upper limit of the platform that they had been working with. It's sort of like if one of your neighbors decided to build a mini water park in their front yard. Your first thought might be, wow, that's the coolest thing to ever happen in this town. I can't wait to see how fun these rides are for myself. But then you go back home to take a shower and do your dishes, and there's no more water left for you. You could say that the problem is with the town's water supply, but it's never been a problem before. Plus, getting more water for the town isn't an easy thing to accomplish. You can blame your neighbor, but let's face it, a front yard water park is just too fun to take issue with. Really, all you needed all along was simply some sort of guarantee of a minimum requirement for how much water would always be at your disposal. A mechanism to ensure that, regardless of how much water there is in the town, and regardless of how fun your neighbors are, you will always have at least enough to take a shower and do your dishes. Of course, what I'm really talking about here is service level agreement. Should there have been a mechanism for minimum service requirement built into the Ethereum platform already, CryptoKitties' success wouldn't have been of issue to anyone other than itself. While everyone was buying and selling pixelated kittens, those other apps of lesser fame would have at least been working properly. CryptoKitties itself would have experienced even greater slowdowns than it did, perhaps leading to freezing and crashing. But at least it would have been of their own doing, a problem resulting from their success rather than someone else's failure. And not such a bad problem to have in the first place, if I might add. So what's the solution, ultimately, you might ask? Is there a way to handle SLA in decentralized infrastructure, where developers and consumers both win?
The way we plan on doing that is by creating a chain or chain agreements where one agreement is an agreement that you sign with an entity that is providing services on the blockchain. So it is one of the nodes in the decentralized network of Orbs. And you can deal with them directly, and they can add the required resources so that you'd get the guaranteed service level. But of course, they wouldn't be necessarily the ones processing your transactions because the network is decentralized. So when you send a transaction to the network, it may be processed by others or by many others for that matter. But the next part of that structure is that whoever guaranteed you an SLA has a smart contract agreement with the decentralized network. And that agreement says that if they're providing the decentralized network with a certain amount of resources, then the network as a whole would guarantee their customer, which is you, the service level that you purchased. So you actually sign a contract with one of the operators in the decentralized network of Orbs, and they actually commit to add a certain amount of resources to the shared pool of resources that the decentralized network is comprised of. And in return, these shared resources would expand the capacity of the network. And the network as a whole would then provide you with the necessary resources so that you'd get your guaranteed level that you paid for.
Service level agreement, like most contractual agreements out there in the world, is the sort of thing that's glossed over by many of us, but very important for what it does. With no single counterparty with which users can come into agreement, we have yet to see exactly what approach works best with SLA in decentralized infrastructures. What we do know is that in order for a blockchain to enter the mainstream as a workable solution for large-scale established businesses, this is one of those things that today's architects will have to get right. Thanks for listening. I hope you had a good time hearing me talk about the dry legal matter of B2C contractual agreements. If you want to continue the conversation, email me at nate@podil.net. And if you're eager for a more exciting topic, catch next week's episode. It's coming soon. This has been the Orbs Podcast. I'm Nate Nelson.
Blockchain. Produced by PI Media.